All right, we're going to take a quick look at what logarithms are. So when you see something like log base 10 of 1,000, the question you want to ask yourself is, what exponent do I have to place on the 10 in order to make 1,000? Well, we know that 10 to the third power is 1,000, and so what that means is that log base 10 of 1,000 is actually 3. So just to play around with this idea a little bit more, let's look at log base 10 of 5,000. So again, the question to ask yourself is, what exponent do you need to place on the 10 in order to get 5,000 now? Well, we can kind of get an idea where this is going to go if we realize that 10 to the third power is 1,000 and 10 to the fourth power is 10,000. So that means log base 10 of 5,000 is going to be somewhere between 3 and 4. Well, if you just punch that into a calculator, log 5,000, what you'll see is that you'll get 3.69897. So you can see it lies between 3 and 4. So again, what that is, it's the exponent that you'd have to put on the 10 in order to make 5,000. So let's play around with this a little bit. In the upper left corner, we have log base 10 of 10. So the question to ask yourself is, what exponent must we place on 10 in order to get 10 itself? Well, clearly 10 to the first power is 10, and so that's why log base 10 of 10 is 1. In the upper right, we have log base 3 of 1/9. Well, we know 3 squared is 9, but this is 1 over 9, so it would be like 1 over 3 squared, or in other words, 3 to the negative 2 power, negative second power. And so for so the exponent we have to place on the 3 to get 1/9, that's going to be negative 2. If you look in the middle on the left, it says log base 2 of 16. So we have to ask ourselves, what exponent must we place on the 2 in order to get 16? Well, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, and 2 to the fourth is 16. Well, so the exponent we need to place on the 2 to get 16 is 4, and so that's why log base 2 of 16 is 4. Next, we have ln of e to the 6th. Now, what ln means is that is log of base e. And so what we need to do is figure out what exponent must we place on e in order to get e to the 6th. Well, clearly, if we raise e to the 6th power, we'll get e to the 6th. So ln, or natural log of e to the 6th, is just 6. In the bottom left, we have log base a of cube root of a. So again, we can kind of follow this pattern. We're really asking, what exponent must we place on a to get a to the 1/3 power, or cube root of a? Well, so that's just going to be 1/3. And then finally, bottom right, we have log base a of 1. So that's really just asking, what power must we place on a in order to get 1? Well, anything to the 0 power happens to be 1. And so a to the 0 power is 1. So therefore, log base a of 1 is going to be 0. Just to play around with this just a little more, we already looked at log base 10 of 5,000. We found it was 3.69897. It turns out if you have a situation like that, log base 10 of 5,000, you could actually write it as log base 10 of, 5 times 1,000. And that will split up into log base 10 of 5 plus log base 10 of 1,000. Well, log base 10 of 1,000 is 3, since 10 to the third power equals 1,000. And so if you look up independently what log base 10 of 1,000 is and what log base 10 of 5 is, you'll find that you get 3 and 0.69897. So you see that we've been able to divide or split up the log of 5,000 into the log of 5 plus the log of 1,000. So in general, there's a pattern that logarithms follow, that the log of a product of, say, a, b, is going to be log a plus log b. So final comment here, really, what are logarithms? If you ever see something like log base a of b, what that means is, and you really have to ask yourself this, is what exponent must we place on a in order to get b? So if it's the case that we can find it, that suppose we know that a to the x equals b, well, what that means is log base a of b is going to be x, so long as a to the x equals b. So hopefully that helps, and best of luck with logarithms.